Hi, everyone. Thanks for joining again. This is another iteration of our Code Unboxed series. If you're following along, we have a number of other Code Unboxed series for different samples of code. Today, we're going to be focusing on Genode. Before we get into it, I do have a couple of disclosures just to run through. So as with any vulnerability disclosure, we do follow a vulnerability disclosure process at TrustInSoft, where any of the code that we're analyzing, we do notify the code owners or responsible parties who are responsible for maintaining the respective code that we've analyzed with a 90-day disclosure notice period to allow for those owners of the respective code to address any of the vulnerabilities and make sure that they're aware that we are going to be publishing these YouTube videos. There is a 30-day reminder that's sent to those respective parties to give them the opportunity to address them. So one thing that we're very stringent on, we don't want to ever release any, or talk about, frankly, any vulnerabilities that may have significant impact without allowing the responsible parties to address those. So today we have Roland, who's going to be running through a little bit of change up of our normal menu. Roland's going to be running through some findings from his code analysis. And Roland, over to you.
Yeah, thank you. So yeah, today we're going to talk about Genode Labs. Genode is kind of some project that I've been looking at for quite some time because if you've seen in past presentation, I've been working on real-time operating system for many years. And what's interesting with Genode is they try to not redo the kernel, but actually build the complete software architecture for a desktop environment and a complete deployable mobile and secure desktop system that applies to embedded and security critical applications. And so their main approach for system design is to divide and conquer, to divide components that would normally be huge into smaller modular pieces. But then, I mean, if one of those central pieces that you see in the graph here would fail, you still have a problem. So all in all, it's making the overall architecture more robust, but you still have to figure out what's going wrong and ensure sufficient quality in each of the components there. The other thing that's actually peculiar is that this entire architecture is done in C++, but in a style of C++ that is surprisingly easy to read. For me, who is just not a beginner, but not so savvy in C++, I enjoy reading that code. So for me, it's actually good. So what I'm going to share here is the findings. We spent a few days to investigate on some core component of Genode. We obviously could not spend the time to analyze the entire platform. Instead, what we decided is to look at the core component, which is the startup runtime code of each application, which is C++ as a base, and then see if we could find anything. So the result, well, actually, I'm showing here the result of what we found, which is 4 issues. But before going into that, I'd like to show some code first. What we looked at first is, okay, actually, did we have issues when we looked at the parsing? The code is C++ 17, and they're upgrading somehow sometimes to 20. But for large parts, there was absolutely no issue with parsing the code with this analyzer, as our front end is capable of parsing C++ 20. We did find a few warnings here and there. There's one that is very common where sometimes they use the class the class name, and sometimes they use struct for the same class. And so there's a warning here. It seems like it's only causing trouble for the Microsoft C++ ABI, which is not a problem at all for Genode, so not really an issue. There are a number of implicit conversions, and all those we could find are actually correctly handled, but still they're changing the sign, so it's a kind of a surprising construct. Still, again, if you know what you're doing, no problem, but it was interesting to note.
And if you're following along, just maybe for viewers, this analyzer, Roland, is our analyzer, right? That we use a TrustInSoft and that we provide to customers to perform formal verification.
Correct. So it's basically this is about TIS Analyzer. TIS Analyzer is a specific analyzer that applies formal methods to basically help you mathematically prove that all the behavior of your software, and it helps you reach zero defect in your software.
Thanks.
So, okay, let's go to the actual results that we found. So one of the first result I'd like to show, it's quite a complex one to understand when you look at it. So the tool tells us that there's an object cast issue, and specifically there's a situation where there could be a different size allocated and deallocated. Rather than going into the investigation of the tool, because Genode already corrected that in their master on GitHub, the best is to look at their explanation, which is basically when you do, there's a placeable class that handles the move semantics for allocations, and when there's that placeable allocation, it may be rounded around the size of the object that it wanted to, and there was a tricky bit where the compiler could actually down round instead of over rounding, and so at least what the code intended was to be equal of the size. So they just added an assert, and at least it didn't seem to show anything, but that was a true issue at the time. Another one that we found was a little more interesting. Let me see if it's this one. No, it's not this one. This one is still in discussion. So that's one of the example that we're not going to talk about because it's still in discussion with them. It's about some logger event. So again, here we have we have quite a complex call stack here. It's going from the main and going through the termination of the code. If we look at the actual call stack in detail, we can see that this is when destroying destructor environment, something could go wrong. If I go in our analyzer here and I reach the issue, the problem encountered, let me go to the analyzer, the problem encountered is that somehow a condition here, we could be dereferencing null. And here, this is the pointer to the class logger, which would be the reference, and that's actually a problem because TMP the object is null. So what we can do, we can see the call stack here, the call tree here that leads to that particular situation, and by using something called the path debugger, we can actually step back and see what's going on. Why is that TMP variable null? We can go back, and here we see that it tells us back to a particular null pointer where the reason for the original the reason why we returned that null pointer and got a null object, a pointer to a null object, to a null pointer to an object, was because there is a situation where the tracing was inhibited. If I click on inhibited, indeed, the value is 1, which means we are in a situation where we're trying to use the logger, but the logger was disabled. Likewise, this is something that was resolved by Genode. Here, There's a specific situation where, well, again, the logger class function returns a null pointer where tracing is temporarily inhibited. And this must be checked, obviously. So there was a missing check somewhere during the destruction of code. And there are some situations where logging is disabled during that time. So is that a security issue? Not really. Is that reachable? Definitely yes. In fact, the reason we can claim that is because the way our tool works is it will go through the code. When you run regular code on the target, it will go through a particular path. And when you do your test, it will evaluate only one path of the code. If you want to do thorough testing, then you need to do to basically manipulate the inputs each time to make sure that it's going through the right path. There are some configurations of TrustInSoft which allow you to do that. In particular, this is something that is difficult to master because if you miss a code path here and you didn't do enough testing, then there may be issues remaining. And that was the case for that logger path. With TrustInSoft, you can still do that, but you can also give some generalized inputs or semi-generalized input where instead of giving single values like would be there in real world, it will be ranges of values, generalized values. And for example, you could give a pointer that is null or not null, or you could give ranges of values for some symbols and specific values for others. And so this allows the TrustInSoft to inspect many more paths. And this is how we could find this particular issue. And again, well, once it was confirmed, it was very quickly resolved by Genode.
So if I didn't, Roland,
Yeah.
kind of know the answer to this already, but just for folks following along, if I wasn't using something like TIS Analyzer, how would I find this?
Well, you'd have to basically do very, very thorough testing to make sure that you test every single condition that could happen, positive and negative, and all the possible values, and trace that. Usually, if you want to do it the absolutely perfect way, you need to write requirements that describe which cases you need to test, which functionality should work in which situation, and then make a test specification and basically describe a complete V model to ensure that your definition is complete and your testing is complete. This is actually very, very, very costly. In fact, if you want to do it exhaustively, even with TrustInSoft, you probably want to do part of that. But with TrustInSoft, because you can give ranges of inputs, you have a much wider proof and demonstration that your system is correct.
Okay.
The last issue I'd
Thanks.
like to show is a little more obvious, and actually we were really, really surprised to find this one, and we initially thought it was, I mean, we couldn't get it. If you look at this code here and you're reading attentively, there is a workaround here for just the purpose of the demo, but in particular, the original code was using that particular construct. And if you read, it's trying to star null pointer. So it is explicitly trying to dereference a null pointer, which for any developer would be obvious should not work. As it turns out, both Clang and GCC accept that construct and will allow building this, which surprised everyone. This is indeed an issue because even when the compiler allows that, this is what is called an undefined behavior. The compiler is actually capable and allowed to optimize it in any way it wants. And so really, you don't know what's going to happen when the compiler compiles that. Again, since then, that has been removed. The change to remove that is much, much bigger because the complete session handling has been redone. Again, and this is mentioned here in the release notes about at-exit handling. So that's a little bit bigger change. So I don't want to just show the diff of the code, but they actually made it made a little point in their release notes. So that's all the findings that we actually found in this particular case. Again, so Gavin, I don't know if you want to say something more on the background here, but what was interesting is we did find a few things.
Yeah, so if you're following along, and like I said, we've got a number of other videos in this series of Code Unboxed, but I guess just in summary, what TrustInSoft Analyzer does, I know, Roland, you went through a couple of examples there. We use obviously formal methods. We apply that within the solution. And I like the fact that you had mentioned earlier, Roland, the exhaustive testing, because that does significantly save a lot of time and effort for customers using TrustInSoft Analyzer, where you're able with generalization to evaluate billions of test results. And then, of course, from a depth perspective, Roland went through a little bit of that tree view of we're going to make sure that we evaluate every single possible code path possible in your respective code base. So if you do want to find out any more information about TrustInSoft, click on the link below, go to trustinsoft.com, and we look forward to sharing a few more of these. Upcoming next is libgit 2, if my memory serves me. Keep me honest, Roland.
Yeah, that's right. So after Genode, where we did find a few things, and they actually corrected them, the next one is libgit 2.
Excellent. Thank you, and we'll see you on the next Code Unboxed.
Thank you. Bye-bye.